Every single day, we're creating this absolute tidal wave of data. It's just everywhere. But how do we actually turn all that chaos into something clear and useful? Well, today, we're going to pull back the curtain and look at the hidden structures that make our entire digital world work. And it all starts with a number that is just going to blow your mind.
So let's just put a number on the table. 500 terabytes. That's how much new data a company like Facebook deals with every single day. We're talking photos, updates, comments, billions of little likes. It's not a stream of information, it's a tsunami.
And that really brings us to the big question, right? How on earth do we make any sense of that? How do you take this chaotic flood of raw facts and turn it into something valuable, something that can, power a business or help you and I make a smarter decision? To get to that answer, we first have to figure out what the goal is. See, it's not just about storing stuff. It's about transforming raw facts into actual value. And that transformation, well, it happens in a few really important steps. Think of it like a pipeline. On one end, you have raw data, just unprocessed facts, like a long string of GPS coordinates from your phone, totally meaningless on its own. But when you process that data to give it some meaning, like plotting those points on a map and seeing a route, suddenly it becomes information. Then, when you apply that information to a real situation, like your phone noticing that route is your daily commute and warning you about traffic, that is knowledge. So the whole point is to get from raw, useless data to actionable knowledge.
But, oh man, getting there was not always this elegant. The very first attempts to manage data on computers using these simple file systems, to put it nicely, they were a complete fiasco. They ended up creating way more problems than they solved.
The main villain in this early story is a little something called data redundancy. This is what happens when the exact same piece of info gets stored in a bunch of different places. So a sales agent's phone number might be in the customer file, and the sales file, and the payroll file. This created what the pros call islands of information, where every single department had its own separate and usually slightly different version of the truth. Total chaos.
And this one single flaw, redundancy, it sets off a whole domino effect of disasters. I mean, with data sprinkled everywhere, security is a nightmare. Data inconsistency? Oh, it's guaranteed. You change a phone number in one file but forget the other two, and now nobody knows what's correct. Of course, this leads to way more typos and data entry mistakes, which creates massive problems with data integrity. Your data just can't be trusted.
And this is where things get really dangerous. It leads to what are called data anomalies. These are nasty glitches in your data. For example, an update anomaly. That's when you change an agent's name in one spot, but it stays the old way in 5 other spots. Or an insertion anomaly, where you literally can't add a new sales agent to the system because they haven't been assigned a customer yet. And maybe the worst, a deletion anomaly, where you delete a customer's record and oops, you accidentally wipe out the only copy of their agent's information. It is a complete and total mess.
And if all of that wasn't bad enough, these old systems had this other critical flaw called structural dependence. Basically, it meant that all the software programs were hardwired to the exact layout of the file. So, if you wanted to add just one tiny new piece of information, like a customer's birthday, you had to go find and rewrite every single program that ever touched that file. It was fragile, super expensive, and made progress grind to a halt.
Okay, so things are looking pretty bleak. But don't worry, because into this chaos comes our hero, the database. This was a completely revolutionary way of thinking, designed from the ground up to fix every single one of those problems we just talked about. So, what is a database at its core? It's a shared, integrated computer structure. And those two words are everything: shared and integrated. It's not a bunch of separate files anymore. It's one central, single source of truth for all the data. And it also stores something called metadata, which is really just data about your data. It's like a table of contents that describes everything inside, making it a self-describing system.
But the database itself is just the building. The real magic, the brain of the operation, is the Database Management System, or DBMS. And honestly, the best way to think about the DBMS is as a super smart, super strict software librarian. You don't just go grab data off the shelves yourself. No way. You make a request to the librarian, the DBMS, and it goes and gets it for you, making sure all the rules are followed and everything stays neat and tidy. Okay, theory's great, but let's make this real. Take a look at this before picture. This is from a simple file trying to track what skills employees have. See the problems jumping out at you? Basic DB manipulation is spelled 2 different ways. That creates inconsistency. And what happens if John Smith learns a 4th skill? You'd have to completely rebuild the file structure. It's just clunky and begging for errors. Now, look at the after. So much cleaner, right? Using a database approach, we've split the data into two separate, logical tables, one just for employees and one just for skills. By doing this, each skill is now stored only one time. No more redundancy, no more misspellings. We can now link an employee to one skill or 100 skills, and we never have to change the structure. It is clean, it's efficient, and it's incredibly flexible.
But here's the thing. This kind of elegant, clean design, it doesn't happen by accident. It's not magic. Just like you wouldn't build a house without a plan, you can't build a good database without a blueprint. You know, this quote from our source material just absolutely nails it. You can't just start throwing data into tables and hoping it all works out. You need a data model. That is your formal blueprint. And that's exactly what a data model is. It's the essential architectural blueprint for your database house. It's that critical design phase where you sit down and map out exactly what you need to track, and, crucially, how all the different pieces are going to relate to each other. And you do all this before you write a single line of code.
And here's the cool part. Every data model, no matter how complex it seems, is built from just 4 basic building blocks. First, you've got an entity. That's just a person, place, or thing you want to track, like a customer. Then you have an attribute, which is just a characteristic of that entity, like the customer's name. Then you have the relationship, which describes how entities are connected. And finally, you have constraints, which are just the rules the data has to follow, like a student's GPA has to be between 0 and 4. That's it.
Now, a super important part of that blueprint is defining those relationships. They usually come in 3 main flavors. You've got one-to-one, like one employee manages one store. Then there's one-to-many, which is the most common. Think one painter can create many paintings. And finally, you have many-to-many, where many students can sign up for many classes. Getting these relationships right is absolutely the key to a powerful database.
Okay, so we've designed our blueprint. We have a plan. The final piece of the puzzle is to see how that abstract plan gets turned into a real, live, working system.
You know, these data models didn't just appear out of nowhere. They've evolved. The early models in the 60s were powerful but super rigid and hard to use. The massive, world-changing breakthrough came in 1970 with the relational model. This was like inventing the automatic transmission for cars. All of a sudden, databases became accessible to way more people. And since then, we've just kept innovating with better blueprinting tools and even new kinds of models to handle modern big data.
This whole process from idea to reality happens in layers. Think of it as moving from a high-level human idea down to the physical machine. It starts with the external model. That's just what a specific user needs to see, like what a salesperson sees on their screen. All those different views get combined into the one master blueprint, the conceptual model. That blueprint then gets translated into an internal model for a specific type of database, which finally becomes the physical model, how the ones and zeros are literally arranged on a spinning hard drive.
So there you have it. We've taken this journey from a chaotic flood of raw, messy facts to a beautifully designed, structured system for creating knowledge. By ditching the old file system fiasco and creating a smart blueprint, we can build databases that are reliable, flexible, and powerful. This planned journey from data to information to knowledge, it really does power our entire world. So now that the chaos is organized, the only real question left is, what will you ask?